slow enough, and the computational power or efficiency of the system should be at least match the level of human beings before we can sort of thinking of rolling out for a general purpose.
Sir, coming back to DK Gupta, sir, these tactile feedback mechanisms and gesture recognition, we have been using them in video games for about decades now. So how far they come in the surgical field, sir?
So as of now, the tactile feedback is the thing which is lacking in the robotic surgery, but now there are robots which have been developed using some piezoelectric tips and certain haptile sensors, which basically measure the pressure of the instrument over the tissue. So that pressure can be measured by the AI, and it will be displayed on the monitor, and the surgeon, the console surgeon who is doing the surgery, can reduce his traction or application of the force or pressure. So these are the things which are being developed.
Sir, and lastly, again, this is the final point of contention, that if anything goes wrong, I know we still don't have a national policy on this, but I just want your opinion, sir. Who should be the one to take the fall? Where and how should the fall be distributed, if at all?
So there are multiple agencies involved in utilization of AI in healthcare system, which right from the development of the machine to the development of the software to the surgeon. So the fall guy has to be surgeon as of now, because as of now there is no system where the human interface has been removed.
Sir.
But yes, if there are algorithms which are bad, then they should be also accountable. In fact, there is a recent white paper in the United States by himself, President Biden, in October 2023, wherein they have brought out the broad as well as the detailed guidelines of utilization of AI in medical field. So probably in the years to come in India, we will also have the similar policies.
Sir. Coming to Naga, sir, who's a specialist in anterior skull base. Now, sir, yours is a very, very subspecialized field with a close coordination between imaging and the surgical specialist. So how has AI or these advanced techniques made inroads into your discipline, sir?
See, one unique advantage of anterior skull base surgery is that almost say 100% of surgery is done using a camera, which is recordable, which is reviewable subsequently. So large number of data is available. So although like other field, we are still in infancy only, but definitely there are various aspects where AI is making inroads, at least on a theoretical level. So like we see in radiology is a field where AI has made most of its impact, because again, as a lot of data is available for it to assess. So similarly, now AI algorithms are available which can analyze the anatomical landmarks, which can pinpoint, okay, this is anterior ethmoid artery. In the sphenoid, it can pinpoint the carotid, it can pinpoint VDN and all. So basically, it can automate the labeling of the CT scan, which may make it easier for younger colleagues to see the scans. And some studies have shown their accuracy to be as high as 90%. If we go to the next slide. So this was for the anatomical part. Now there was a attempt which was made to see the pathological condition also. So CNN, which is a fancy word for convoluted neural network, it was used to assess the inflammation of osteomeatal complex. And the study says that it could accurately identify the blockage or pathology in the osteomeatal complex in 85% of cases. And the cases where it was not accurate, even those cases were kind of debatable in many areas. But then again, it brings us to the question that how the algorithm reached that conclusion. How did it, what was its thought process? And as Brigadier Datta in the morning session also brought out that most of these algorithms, they're black box algorithms. We really don't know how they are functioning. So that is one major criticism for AI. We have not much clarity how the AI is working, how it is processing the data, and how it is reaching at conclusion in many aspects. Not all, but in many, many aspects. Again, no, this is very interesting thing which article I came across. It is a study done in China regarding detection of nasopharyngeal carcinoma from endoscopic images. So we all know nasopharynx is a very occult kind of a location, and it is further compounded by presence of adenoid hyperplasia to varying degrees, even in adults. So therefore, there is the biopsy yield in such an area is on the lower side. So what they did is in this study, they fed the system around 28,000 images of biopsy proven nasopharyngeal carcinoma. So that was to train the model. And subsequently, after training, the model was again fed with 5,000 undiagnosed images. And to the surprise of the people who were doing the study, it showed an accuracy of 88.7%. And they compared this accuracy with expert oncologists, and it was found to be better than them. Their accuracy was around 70%, and the accuracy of this model was 88.7%. And this is without taking any other input into these scenarios. Suppose the authors have mentioned, suppose they have taken the input about imaging or the Epstein-Barr virus viral DNA load, the accuracy could still be further increased slightly in these cases.
Sir has brought out a very pertinent point here regarding classification models. Now, classification models are the most popular AI models, the ones we get in the news. Those are classification models. Right now, generative ones have taken the first place, but even 3 years ago, classification models were. Now, the problem with classification models is that, like this case, a study has to be read very thoroughly and the design has to be understood. What were they looking for? I'll give you a simple example, if I may be permitted, sir. The system of elections in our country, it's called the first past the post. In a given set of candidates, whoever reaches, he doesn't even has to cross 50%. He has to just be the maximum, which means most of the MPs or MLAs who are elected are representatives in different houses. They're all actually, most of them are minority vote. They got minority vote. Some got 30, which means 70% have voted against them. But that vote has got distributed between various other candidates. Similarly, most of our AI models work on that principle. First past the post, which means that if you've got a binary classifier, your classification model is only as strong as your the proportion in the proportion of data points in between. If you have too many cancers on your training data and too few of non-cancers in your training data, then you are at every risk of developing a biased model. And the bias increases as you go on in increasing number of classes. So while developing such models, we have to kind of be careful so that we don't get into the loop of first past the post. Again, Naga sir.
So again, this is a study which was done to use AI models for predicting CSF leak in skull-base surgery. CSF leak is the most dreaded complication for any advanced skull-base surgery. It can lead to meningitis, it can lead to pneumocephalus. Occasionally, fatal outcomes can be there. So this study basically whatever algorithm they had developed, it took into account pre-operative risk factors such as the BMI of the patient, the tumor size, and the repair techniques, like did they use a artificial dura or a tissue sealant, or did they use any autologous materials? And based on that, they try to predict both intraoperative as well as post-operative CSF leaks. And the study concluded that the neural networks, they outperform the traditional statistical tools. It's not that it's comparing it with human intelligence here. It is comparing it with the traditional statistical tools in this particular study.
So again, sir, you have brought another pertinent point, the clinical applicability of AI models. Now, before the publication of this paper, you had a system of predicting CSF leak. Was that good enough, very good, or would it be augmented by this publication, sir?
Certainly augmented by this system, because what it can help is it can help us to perhaps better predict the likelihood of a CSF leak in a patient also it can help us to counsel that patient. So suppose we know certain risk factors which are there, like the size, BMI, and based on this model, if we find that a particular size or the particular BMI has been found to be a more important risk factors, we can counsel the patient that there's more likelihood of a CSF leak in your case. So, or we can also be better prepared to tackle that leak.
Sir. So I guess gradually these things will come up in textbooks as well as time moves ahead. Again, because surgical planning is one of the essential steps.
So gradually, see, all these innovations will help us to apply AI in surgical planning. As see, there is already automated analysis of steps in a pituitary surgery is already on, because see, pituitary surgery, if I may put it, it's very regimental in nature, in the sense the steps are very, very predefined. Like you will start by lateralizing the middle turbinate, identifying sphenoid, then widening, and so on and so forth. So this study basically it audited numerous videos of this surgery and figured out how much average time was being taken for each and every step, which step was more critical as far as the outcome of the patient was concerned, and which step, if not performed to its optimal level, led to complications such as maybe residual tumor or a CSF leak. Also, like there have been models now, since, as I told, in skull-base surgery, anterior skull-base surgery, most of the data can be either recorded or almost the entire surgery is on camera. So therefore, it could be used to automatically generate the operative notes also. Prediction of navigational positions during endoscopy. Now, we had a very nice talk in the morning regarding use of neuronavigation. What we need to keep in mind is neuronavigation uses pre-operative imaging to predict the position of the landmarks during surgery. It does not take into account the changes in the particular landmarks which may happen during the surgery. So where it comes in handy is, suppose there is a tumor which is displacing the carotid laterally, and while during surgery, we remove certain parts of tumor, there is a possibility that the position of carotid may move by a few millimeters. And that is not taken into account on the pre-operative imaging. So now there is an ongoing project in Pittsburgh where they're using AI algorithms dynamically during surgery. While the tumor is being removed, based on the amount of tumor being removed, the fresh position of carotid is being predicted by this model so that the surgeons can be more accurate. So still in infancy, long way to go, but it has a role to really change the decision of the surgeon, how far he can go, how safe he can be. Other areas, again, these are imaging based, where we can differentiate in certain pathologies which look very similar on CT scans, like inverted papilloma or nasal polyps. So probably it can prepare us better for surgery. Deep learning has been used to identify the possibility of malignant transformation in inverted papilloma. So it's so much so that certain algorithms have been able to predict which part of inverted papilloma is more likely to have a malignant transformation in it. So how it can help the surgeon? We can not use powered instrument in that particular area, like microdebriders, and remove that area using conventional black forceps and all, so that that tissue is available for histopathology. And last but not least is editing of surgical videos. Now, as I told, these days we have high definition cameras going on to 4K and 8K. So when we record the surgical videos, they are really, really large files. And these files are available with us, but we are not able to archive them properly, because as they are large and it's difficult to go through a 3-hour or a 4-hour long surgical video. We all have wonderful software to edit these videos. We call them residents. But we all need to understand that it is very, very exhaustive. So this study, which is an ongoing project in which they basically use automatic summarization of endoscopic skull-based videos through object medical imaging and some hidden Markov modeling. So this study, they were able to see that they are able to reduce or edit the video by 90% while retaining about 80% of useful information. So how they do it, like they automatically, the algorithm, it removes all the blurry images, the images where cleaning the lens or where we're doing irrigation, and it has the ability to identify the critical steps, and those steps are highlighted during the editing process. So I feel this is one area where AI, as far as skull base is concerned, is likely to come up fast, because there won't be many ethical issues in this particular area.
Sir, now, in this previous slide, you mentioned that